So in today's class, the topic that we are going to discuss is actually about recursion. Recursion or recursive functions. These are actually a specific type of functions in any programming language. Uh, Everyone knows what is meant by the term recursion. Recursion means something that is repeating, right? For example, uh, let me write a function to find the sum of n numbers. Uh, in mathematical terms, it will be written as f of n is equal to 1 plus 2 plus 3 plus etc. plus n, right? So this is how you normally write a function to find the sum of n natural numbers. And you have another way of doing it also, that which is in fact n into n plus 1 by 2, but that is not what we are looking for now. And the corresponding C implementation for this function will be, everyone knows about that. I will write, so the function int f. F is the name of the function, or rather I would use a better name for that. Probably this is sum. I write sum. Similarly, I can use the same sum here. Sum of n is equal to 1 plus 2 plus 3 plus etc. plus n. So in the programming language statements, or in the C programming statements, it will be translated into in sum. Probably I am passing the total number of integers up to which I need to find the sum, right? So in sum int n, and here what I am doing is I am declaring a variable called I, and what I do is just a for loop, right? For I assigns 0, I less than n, oh sorry, this is not actually I assign 0, but here it is from 1 onwards, right? 1 plus 2 plus etc. plus n. For I assigns 1, I less than or equal to n, I plus plus. What I will do is I will do something like a sum. Sum is the name of the function, right? So I will write f of n, s plus I, and I would initialize the value of s of 0 here. So s of n s plus I. So the for loop is over, and finally I will return this yes. So this is how the mathematical function sum of n of n, 1 plus 2 plus 3 plus etc. plus n, uh, this will be translated into. I hope everyone knows how we can write this function. There is nothing complicated about this thing. Also, we have been discussing these topics for the past probably 2-3 classes. And here what you can see is we are using a loop, right? And inside this loop, we are varying a loop variable I from 1 to n, and for each value of I, we are adding the value of I with I with the variable s, and this is how we find the sum. This type of a program is what you call iterative program, or iterative. This is iterative because we are iterating over a particular variable, and in each iteration means each occurrence of the loop, and in each iteration we are updating, or we are finding, or we are processing certain statements. Here the statements that we are processing is uh, the set of statements that we are processing is actually s of n s plus I, right? This is what you call an iterative program. Does everyone understand what an iterative program is? Shall I check your comments? Okay, Ahmad, Nathan, Gobiga, right? Everyone knows that. Deepak, yeah, Akash, right? Everyone knows what an iterative program is. And the same program, I will write it in a different way, or the same function, I will write it in a different way. See, shall I write it in this format also? That is probably sum of n assigns 0 if n is equal to 0. Otherwise, n plus sum of n minus 1 otherwise. Is this also correct? Is this function also doing the same purpose? Can you comment on that? Does the same function also do the same computation of sum of n numbers? Shall I check your comment? This is simply mathematics. Yes, right. Ahmad Gobi. Yeah. I will explain that. So here, what are we doing? Sum of n assigns 0. I mean, this type of functions with the multiple cases. That is what we call. This is the first. This is actually the. Oh, this is the first case, and this is the second case, right? And what is the first case? If the value of n is 0, of course, that it will be simply 0. It will simply return 0. If the for any other value, for example, if I give the value of n as 5 and I give us 5, then what happens? Sum of n. I need to find sum of n. Right? Sum of n means I need to find sum of 5. So n is not equal to 0. N is 5 here. So what should I go to? Where should I go to? I need to go to this statement. That is n plus sum of n minus 1. What is n here? N is 5. 5 plus sum of n minus 1. What is that? 4. 5 plus 4. So what is actually this evaluated to 5 plus? How is sum of 4 evaluated to? That is 4 plus sum of 3. This is nothing but 5 plus 4 plus. How is sum of 3 evaluated to? That is 3 plus sum of 3. Right? Again, this is evaluated to 5 plus 4 plus 3 plus sum of 2 is evaluated to what? 2 plus sum of 1. Right? This is 5 plus 4 plus 3 plus 2 plus sum of 1 is again evaluated to 1 plus sum of 0. And we all know what sum of 0 is. Sum of 0 is what? Sum of 0 is 0, right? If the value of n is 0, then this will be simply evaluated to 0. So I write it as 5 plus 4 plus 3 plus 2 plus 1 plus 0. What is the expansion? What will be the expansion? It is 15, right? So in this way also, we can find the sum in contrast with the iterative program. Here we haven't used any loop at all, right? We haven't used any loop at all, and this kind of a function is what you call a recursive function. Why is it called a recursive function? Recursion means a function calling itself. A function calling itself is what you call recursion. Function calls itself. This is what you call recursion. So here you can see that here the name of the function is sum, and on the right hand side also you can find the same function. You are trying to expand a function called sum, and the expansion itself the same function appears. That is what you call recursion. So let's try to write the corresponding C program statements. So let me write the corresponding C program statements here. How will I do that? Again, everyone knows how to convert a mathematical function to C program statement, right? So here, sum of n, again, int sum, int n. This is the signature of the function. And here, what should I do? There are two cases. The first case is if n is equal to 0. If n is equal to 0, what should it return? It should return 0. Otherwise, for any other case, what should I return? I should return n plus sum of n minus 1, right? So I just translate these statements into C program. The first thing is if n is equal to 0, I will return what? 0. Else I will return n plus, I will return n, I will return n plus sum of n minus 1. So this function is over, right? And this is the function to find, this is the recursive function to find the sum of first n numbers. And here you can see that the name of the function is actually sum. The name of the function is sum. In the expansion also, the same function actually appears, right? This is what you call a recursive function, or this is actually a recursive function to find the sum of first n numbers. So do you understand this program, or do you understand what exactly recursion is? Or should I explain more? Shall I check your comments? Okay, yeah, Ahmad, right. Any question? Or has everyone understood what recursion is? Yeah, Angel, right, fine. So I think we can move ahead with this thing. Uh, Now suppose I am continuing to write the entire program here. So what I do is I have a hash include std io.h here. Now I am completing the entire program. So here I have this void main or in main, whatever you like. I write void main, and I have a this int n. Now scanf percentage d ampersand n. I am reading the value of n. Now I am trying to find the value of n, right? Say something like I have int n, and I have a probably, yes, I write something like s of sum of n, and finally I am printing the value of it. Printf percentage d backslash n, yes, right. So this is the whole program. Now let's try to analyze this program, how this is going to work, right? I mean, the working is similar to the one that I showed earlier, as in the case of a mathematical function. So here, everyone knows that we are always starting the execution sequence from this void main. So we start from here. We have int here n and s, right? And here scanf percentage d ampersand n. So I am trying to read the value of n here. So this is n. I have this n here and n. And suppose I read the value of n as probably some 3. That's enough, right? 3. And now I invoke s of n sum of n. So first of all, I need to find the value of sum of n. I need to expand the sum of n, and then after executing or after finding the value of sum of n, I need to assign that value to the variable s, right? So there is some variable called s that is here. This is here. This is actually s. I need to assign a value here, but that value will be got by obtaining, or by that will be obtained by calling the sum of n. So what I am calling is sum of n, sum of 3. This is what I am calling. Now when I invoke this sum of 3, I come here, I have the sum of 3, and the sum of 3 here, what I check is if n is equal to 0. Here the value of n is 3, right? If n is equal to 0, is the value of n equal to 0? No, right? Then we go to the else part. Now it returns n plus sum of n minus 1. That is 3 plus sum of 3 minus 1, 2. That is, the sum of 3 is actually replaced with 3 plus sum of 2. Again, this includes a call to sum of 2, right? This includes a call sum of 2. Again, we go to the sum function, and the value of n is 2 here. It is not equal to 0. So we go to the else part, that is n plus sum of n minus 1. That is 2 plus sum of 2 minus 1, which is actually 3. So this call is replaced with 2 plus sum of 1, right? Again, I have a call to sum of 1. And this sum of 1, I go to the beginning of this function. If n is equal to 0, no, it is not equal to 0. So I have to go to this else part. That is, the sum of 1 will be replaced with 1 plus sum of 0. Again, there is an invocation of sum of 0. So we come again here and n is equal to 0 here. So it returns 0. That is sum of 0 is replaced with a 0. So there is no other function called remaining. And the sum will be 0 plus 1 plus 2 plus 3. That is actually 6. So the sum of 3 will be replaced with a 6 and that value will be assigned to the variable s here. So s gets the value 6 and finally I print %d backslash and s. So it will print the value 6. So this is the output. So does everyone understand how a recursive function works using this particular example? Does everyone understand that, or should I explain that more? Yeah, Deepak, yeah, Kevin, right. Anamika, yeah, right. I think almost everyone understood this. It should not be a big issue. And this recursion is actually a very good tool in the hands of programmers, because uh, you can see that this is the recursive function, and this is actually the recursive function, right? And this one does not include any loop. This contains only simple statements. If n is equal to 0, return 0, else return n plus sum of n minus 1. So this one does not include any loop, and it's a pretty straightforward way of writing a function. Let's write another function. So you write the question, write a recursive function to find the factorial of a number, right? A recursive function to find the factorial. Write a recursive function to find the factorial of a number. Everyone knows what a factorial is, right? That is 4 factorial is equal to 4 into 3 into 2 into 1, right? This is what you call factorial. Or I will write n factorial is equal to n into n minus 1 into etc. into 1. This is what you call factorial. In iterative terms, it is very easy to write this function. I would write something like int factorial, so probably int n. N stands for the number of numbers. The n stands for the number of which we need to find the factorial, right? So here what I do is I declare a loop variable, probably I. Then I have something called we are finding the product, right? So I initialize this prod as 1, and what I do is I can actually multiply something like 1 into 2 into 3 into etc. into n. That is possible, or I can multiply n into n minus 1 into etc. into 1. Both way it will be correct, right? So I am using the second way. That is this way. I am trying to use. For I assigns n, I greater than 0, I plus plus, sorry, I not I plus plus, it is I minus minus. I minus minus, I write the code as prod assigns, prod times what I. Finally, return this prod. So this is the iterative way of writing the function to find the factorial of a number, right? Very simple, very straightforward. Now, can you write the or can you convert this program into its recursive counterpart? How will you convert, how will you write the corresponding recursive function? First of all, I will write it in a mathematical way. I will write it like the factorial of n is equal to, say, if it is 0, what will be its factorial? What is the factorial of 0? Yeah, it is 1, right? 1 if n is equal to 0. 0 factorial is always 1. Otherwise, what should I do? I will write n times factorial of n minus 1. Otherwise, right? You can check this. Say 4 factorial is equal to 4 into 3 into 2 into 1, right? And this is nothing but this is 4 times this 3 into 2 into 1 is what? Factorial of 3, right? Again, factorial of 3 I can expand as 3 into factorial of 2, right? And factorial of 2 I can expand as 2 into factorial of 1. And factorial of 1 I can expand as 1 into factorial of 0. And I know what factorial of 0 is. Factorial of 0 is nothing but 1, right? So this is how I find the factorial using the recursive method. Does everyone understand? See, once you uh, have the idea of developing the function in a recursive way, in a mathematical format, then everything is done. You just need to convert that into C programming statements. So, do you understand this? Yeah, I think there was some comment. Uh, I couldn't. Yeah, no comment, right? So, can you write the corresponding recursive function here? It is straightforward, right? Once again, if you have this mathematical format, writing the recursive function is very easy. So I write int factorial int n. Easy, right? First of all, I need to check whether n is equal to 0. If n is equal to 0, then I will simply return 1. Else, return 1. N times factorial of n minus 1. That's all. So this is the function to find the factorial. This is the recursive function to find the factorial of a number. Very easy, right? And here, one thing that whenever you are writing a recursive function, the first thing that you need to make sure is that you have the you have the stopping condition in your function. What is the stopping condition here? Uh, what is the just a moment? Please hold on. Hello, hello, hello. അതെ 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 ഹലോ അതെ അതെ പറഞ്ഞു പറഞ്ഞു ആ ഉണ്ടായിരുന്നു അതെ നാളെയോ ഞാൻ സാറ്റർഡേ വരാം ഞാൻ വർക്ക് ചെയ്യുന്ന ആളാണ് ഞാൻ കോട്ടയത്താണ് വർക്ക് ചെയ്യുന്നത് ഞാൻ സാറ്റർഡേ വരാം അതുകൊണ്ട് ഞാൻ സാറ്റർഡേ വരാം ശരി 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 ഓക്കെ so I am back. So the first thing that you need to make sure in your recursive program is that you have your terminating condition. This is what you call the terminating condition. This is when the condition actually, or the infinite number of recursive function calls, or the function call sequence actually terminates on this particular condition, right? That is when n is equal to 0, there is no more function call at all. It is actually returning a constant value, or it's returning a numeric value here. Otherwise, it is returning a recursive value. Here there is recursion. The fact function is called again and again, right? The first thing that you need to make sure in your factorial function is that you have this terminating condition as the, if possible, the first statement of your function. And once you are sure that you have got the terminating condition, you can continue with uh, the other conditions or other cases, right? Otherwise, the problem will be that the function call can result in infinite loop. Now let's write another recursive function also. Write a recursive function to find the write a recursive function to find the nth term of a Fibonacci series or Fibonacci series. Write a recursive function to find the nth term of a Fibonacci series. Normally, everyone knows what a Fibonacci series is, right? A Fibonacci series is nothing but 1, 1. Now we add these two things, 1 plus 1, 2. Then this and this 1 plus 2, 3. Then this 2 and 3, which is actually 5. Then this 3 and 5, which is 8. Then 5 and 8, 13. The series that goes like this is what you call the Fibonacci series, right? And this is actually a naturally occurring series. For example, if you observe the petals of a flower, that will be the number of petals will be a member from this series. For example, you can observe flowers with 3 petals or 5 petals or 8 petals or 13 petals. So that is why it is called a naturally occurring series. Or if you observe the delivery pattern of rabbits, or the special kind of ratio called the golden ratio, all these are actually in this series. So that is why this is a natural series. Now the question is to find the nth term of a Fibonacci series. You know that this is the first term, this is the second term, this is the third term, fourth term, fifth term, sixth term, seventh term, right? And you know that if you want to find the seventh term, that is a sum of sixth term and fifth term, right? F of 6 plus f of 5. Say I write F stands for the Fibonacci. F of 7 is actually equal to F of 6 plus F of 5. F of 25 will be equal to F of 24 plus F of 23, right? So you can say that F of n is equal to, nth term will be equal to F of n minus 1 plus F of n minus 2. What about this f of n minus 1? F of n minus 1 will be equal to f of n minus 2 plus f of n minus 3, right? F of n minus 2 will be equal to f of n minus 3 plus f of n minus 4, right? And what should be the terminating condition here? You know that f of 1 is equal to 1 and f of second term, that also will be equal to 1. First term will be equal to 1, second term will be equal to 1, and after that any term will be equal to f of n minus 1 plus f of n minus 2. That is, it will be the sum of its previous two terms. So I can write it in the mathematical way in this format, right? That is, f of n is equal to, say, I will write the terminating conditions first. So it will be 1 if n is equal to 1. It will be again 1 if n is equal to 2. In all other cases, it will be f of n minus 1 plus f of n minus 2. Otherwise. So does everyone understand how we can mathematically represent this Fibonacci series? Nth term of a Fibonacci series. Does everyone understand this? Okay, Ahmad, when base tends to 0, first time 0 alle, okay, first time നിങ്ങൾക്ക് എങ്ങനെ വേണമെങ്കിലും എടുക്കാം. First time വേണമെങ്കിൽ നിങ്ങൾക്ക് 0, I mean, there are multiple versions. അതായത് ചില ഫിബൊനാച്ചി സീരീസ് ഇങ്ങനെയാണ് തുടങ്ങുന്നത്, 0, 1, 1, 2, 3 എക്സെട്ര, ഇങ്ങനെ തുടങ്ങുന്ന ഫിബൊനാച്ചി സീരീസ് ഉണ്ട്. അല്ലെങ്കിൽ ഇതിനെ അങ്ങ് ഒഴിവാക്കി കളഞ്ഞിട്ട് ബാക്കിയുള്ളത് 1, 1, 2, 3, 5 ഇങ്ങനെ തുടങ്ങുന്ന ഫിബൊനാച്ചി സീരീസും ഉണ്ട്. നിങ്ങൾക്ക് ഏത് വേണമെങ്കിലും എടുക്കാം. ഞാൻ ഈ സെക്കൻഡ് എടുത്തെന്നുള്ളതേ ഉള്ളൂ. നിങ്ങൾ മറ്റേതെടുത്തെന്ന് പറഞ്ഞാലും പ്രത്യേകിച്ച് വലിയ വ്യത്യാസമൊന്നും ഉണ്ടാവില്ല. ഈ ടെർമിനേറ്റിംഗ് കണ്ടീഷനിലുള്ള ചേഞ്ചസ് മാത്രം. n is equal to 1 ആണെങ്കിൽ it will be 0, n is equal to 2 ആണെങ്കിൽ it will be 1 മാറുന്നു മാത്രമേ ഉള്ളൂ. പ്രത്യേകിച്ച് വലിയ വ്യത്യാസമൊന്നുമില്ല. റൈറ്റ്? ഡസ് എവരിവൺ അണ്ടർസ്റ്റാൻഡ് ദിസ്? മനസ്സിലായോ പറഞ്ഞു? മനസ്സിലായോ? യാ ഗോപിക, റൈറ്റ് റൈറ്റ്. വാട്ട് അബൌട്ട് അതേഴ്സ്? ഞാൻ ഈ ഐ എം നോട്ട് ഗോയിങ് ടു റൈറ്റ് the corresponding C programming statements for this function. That is actually left as a homework. So you can actually do some sort of practice and come up with probably your program. And anyway, I think we can stop our class here today. And even if we start the next topic, that is not going to be over in the next 20-30 minutes. So in today's class, we have learned an important concept called a recursion, and recursion means a function calling itself. That is what you call recursion, right? And we have seen how we can write or develop programs using recursion, and how we can unroll the entire calling sequence of this recursion to produce the original answer. We have also seen that how we can expand a recursive function and what happens when we expand a recursive function. And we have seen that the recursion is a very powerful tool in the hands of a programmer. Many very complicated functions can be easily written using this kind of recursive function technique. And I think we will see a lot of recursive functions as we progress in our semesters. Maybe when you are going to practice your data structure classes, or when you are going to practice your probably operating system classes, you will see a lot of recursive functions. And this recursion is a very fundamental idea of developing programs in any programming language. And I think with this we can end the class here for today. Thank you.